Hi everyone. It's a short one this week, but I saw lots and lots of little tiny mistakes in people's code, so I think you should definitely check out this solution video. So a lot of people had max methods with a lot of ifs and elses, and those weren't wrong, but I just want to remind you that in, I think 2 problem sets ago, we learned that you can combine math.max and nest it within itself. So a much shorter solution would be find the max of B and C, and then that's the second input for finding the max between A and whichever of these two is bigger. And so then you can put the whole thing on one line. Similarly, if you had 4 inputs, you could first find the max of A or B, then find the max of C or D, and then find the max of each of those two. And again, it's all a one-line solution. Okay, lots of people had the following wrong answer. So they were calculating the average, and the 2 inputs are ints, and so they add them together and divide by 2, which is also an int. So part of my goal for this problem was testing to see whether or not you would remember about integer division from 2 problem sets ago, and a lot of people didn't. So be aware that in this class, a lot of the stuff we do is going to build, and so I'm going to expect that you remember previous lessons and apply them to future lessons, because I've very carefully kind of layered the learning so that you'll need to use the stuff that you've learned before. So a lot of people cast this expression to be a double, which works just fine. Some people cast each of these to be a double. A really short solution is, instead of saying 2, make it 2.0. Like that. And that treats 2 as a double, and so then no integer division will happen. Also, it's a little bit pointless to declare this variable if you're just going to return it on the next line. So a really short, nice solution would be this one-line solution, where we add them together, divide by the double 2.0, and immediately return it. As a side note, I saw a lot of people with main methods where they were running other methods that they'd written, but ignoring the return values. And that's like, I'm having trouble understanding why you would be doing this. Because your methods don't display anything. They return an answer, but yet you're not printing the answer or saving it into a variable. So this line is doing really exactly nothing. So yeah, I just noticed that, and that's strange. And you should try and not do stuff that doesn't make logical sense to you, or that doesn't appear to be doing anything. Okay, is prime. So a lot of people had this nice solution to is prime, where they used their count factors method, and they asked if there are exactly two factors, then yes, it's prime. Otherwise, no, it's not prime. Let's copy this. I want to show you a way of doing this sort of shorter and nicer. Okay, so here I am in IntelliJ. I've pasted that is prime method and written my own count factors method. And then as a little tester inside main, I'm looping num from 2 up to 23, and I'm printing each number and whether or not it's prime. And when I run it, as you can see in a minute, is it running? Oh, it's down here. If I scroll up, 2 is yes, and 3 is yes, and 4 is no, and 5 is yes, and so on. So you can sort of hand check to make sure that makes sense. All right, so on to what I was saying. Here we're evaluating this expression. So if this thing is true, then we want our method to return true. So I mentioned in problem set 1 that you could do this. You could define a Boolean variable called result, where you can store the result of this calculation, or not calculation, you can store the result of this Boolean expression into a Boolean variable. So let's actually maybe name it better. So has 2 factors. So has 2 factors is going to be true or false, depending on how this evaluated. And so then I could say something like, if has 2 factors is true, return true, otherwise return false. That's a little silly, though, because notice that if has 2 factors equals true, I'm returning the same value as what's inside has 2 factors. If this is true, I'm returning true. If this is false, I'm returning false. So maybe it's faster to just say return whatever this is evaluated to be. Because remember, if this is true, then we'd want to return true. And if this is false, we'd want to return false. And so once you've started to think about it this way, then it's maybe pointless to have declared this in the first place because we're really just trying to return whatever this evaluates to be. So the kind of single line best solution is going to be return whether or not count factors is equal to 2. So when our method runs, this part will evaluate to be true or false, and then we just immediately return it. Okay, last of all, let's look at a solution to find prime larger than. So the idea is it takes an input, and it should return the smallest number larger than 13, which is prime. So in other words, return the smallest prime larger than this input. All right, so I want to, rather than just show you the solution immediately, I want to sort of walk you through how you might go about thinking about this if you were having trouble sort of figuring it out. So I like to try and write things in pseudocode. And you don't have to sort of start with the first line of code and end with the last line of code. You can write down all of the things that you know your program will need to do and then reorder them as a way of helping you figure out how to do this problem. So I know at some point I want to test if a number is, here, let's write this in a comment. I want to test if a number is prime. Like what number do I want to test if it's prime? I guess I want to test all the numbers larger than num. But I can't test all the numbers at once. I can only test one number at a time. So let's define like my test num starts at num plus 1. So now I've got like a specific number that's going to start as 1 larger than my input. And then I'm going to test if the test number is prime. And if it is, then I'll return it. And if it's not, then what do I want to do? I guess I want to like add 1 to test num and do it all again. So this captures all of the parts that I know the solution needs to have. It's got this idea where I've got a number that starts 1 larger than this, and I'm going to over and over again test it to see if it's prime and then add 1 to it until eventually I find a prime. Okay, so this is not written in the way that it's going to end up being, though, because it won't actually end up making sense to have an else statement. So what I want to focus on is whenever you're doing something over and over again, you know you're going to need a loop of some kind. And so you could think, what kind of loop should I use? Should it be a for loop? Should it be a while loop? Should it be a do while loop? Usually you only use a for loop in cases where you want to loop a fixed number of times and you know how many times that is. Here we don't know how many times we're going to have to add 1 until we eventually run into a prime. So I think it makes more sense to use a while or a do while loop. So I could do something like this. I could say, all right, like let's start the number at 1, and then we'll say like, let's test to see if it's prime. While is prime, test num is false. So like while it's not prime, what do we want to do? So we've covered this. I'm testing if it's prime. And then, while it's not prime, I'm going to keep looping here. When it is prime, like when this is true, then the while loop will stop. And so at the end, I know I'll return it. What's it? Test num. All right. And then what I want to do on the inside here, I guess, is add 1 to test num. So now I'm almost at code. I'm saying let's start at 1 larger than num. So here I'm going to start writing in code. So I'll say, int test num equals num plus 1. And then I'll say while is prime test num equals false. Let's increment test num. So as long as it's not prime, let's keep adding 1 and going back and retesting it over and over again. And then eventually it will be prime, and then we'll return whatever it was. So that seems like a pretty concise solution if it works. Just a quick note, most programmers wouldn't write equals false. Most programmers would use not. So they'd say, they'd use the bang, which stands for not. So they'd say, well, it's not true that test num is prime, then do that stuff. And that's just the same thing, a little bit shorter. Okay, so let's run it. We know what the answer to this is. We know what the first prime number larger than 13 should be. I think it should be 17. And there it is, 17. Great. Let's do a big one. Oh, we didn't have to go too far to find a prime. That's nice. I wonder which is the next one larger than that one. Oh, twin primes. Now all the way up to 37. Okay, well, interesting. So this is not the only solution. You could have used a do while loop if you want. Well, here, let me show you something someone else did. So they did this. They said while true. So this just loops forever. And then they put the test in an if statement. So they said if is prime test num is true, then return test num. And then they added one to test num. And then out here, they just returned 0. And this actually, is my ID. Okay, so my ID isn't even going to let me do this. It says unreachable statement because this while loop literally can never exit because true is always true. So this is another solution. A different thing you could do is make it a do while loop. So I could say, if we didn't care about keeping this number around, I could do this. I could add 1 to num as the first thing that happens. And then I could say keep doing that while it's not true that num is prime. And then I could return num at the end. So that's another kind of different but equally short solution. I'm starting by adding 1, and then I'm testing if it's not prime. And as long as it's not prime, I'll go back up here and keep adding 1, and then eventually it is prime, so I return it at the end. So same kind of thing as the while loop. Okay, I hope this was helpful. Good luck on next week's.